Hello, physics kids. We want to just look at how we would do a lab write-up. In every case, I am looking for a very simple, clear lab write-up. Every lab we do should be simple and clear. We generally are only looking at one thing at a time. I don't want you to leave a lab and have some uncertainty about what we were doing there. This should all be very straightforward. So, for example, for labs 1 and 2, and we can really pair them together because they're similar and we get to a quick conclusion. This year I have to sort of compartmentalize and move a little faster. So, title: Physics Lab 1 and 2. Silly walk and distance determination. Now, if you've already started doing this and you've made 2 separate labs, that's fine, no problem. But if you haven't done it, you'd like to put them both together, this is great. I don't want a lot of effort on your part to do these labs. I want you to see what we did, see it very simply, and make sense of it, and incorporate those lessons in your understanding of physics, and move on. So, what is the purpose? Okay, 1, to learn to take physical data. Well, how is that different from other stuff? Well, I hope you understand that your significant figures are really considered heavily here. When you take your time, do you go to the nearest hundredth of a second? I hope not, because that's nonsense. You cannot get the stopwatch to stop perfectly on a hundredth of a second. You are the error in this timing, so a tenth of a second is within what you can do. So things like that. So to learn to take physical data, practice velocity formula. There's a third one here as well, okay? To begin to understand the range of numbers to learn that uncertainty produces a range in the output. Right? So when we're looking at the unknown distance, you're not giving me a distance. That's the last thing I want. I want a range of possible distances that is, from 60 meters to 73 meters. If that's what your numbers say. If your numbers are able to give you 62 to 66 meters, great. It doesn't get you more lab points at all. All I want is that you understand how well you can manage to get through this experiment and that you're giving me an honest range. Excellent. So what's the material? Certainly stopwatch. And then your known and unknown distances. Okay? Those were your materials. This is a very simple lab. All right? Method. Now I'd like you to indicate what your method was. So everybody will probably have a little bit different of a method. But in all cases, method is step 1. Walk known distance and measure time. 3 silly walks. Great. 2, repeat attempting to keep same velocity. And 3, determine range of velocities for number 2. Okay, so you want the range of velocities for using the, well, no, maybe 4 would be time or determine time for unknown distance attempting to walk at constant velocity. 5. Record range of times. All right, everything here is about the range. And then 6, calculate range of possible distances. All right, okay, you see that down there. Calculate range of possible distances. So at the end of this, you have your range of possible distances, and with any luck, the actual distance is somewhere in between. If it's not, you don't lose points. Everything is about a process here, learning to understand that. So if you look here, I've shown you what the data table would look like for this. Okay, the data table for the silly walks, all right, you have distance, time, velocity. Now, why did I put distance in front? Well, when you do your velocity calculations, how do you do it? It's distance divided by time. So you can see, putting things in your data table, that is the way you're going to calculate them as much as you can. That's good physics. So you're not having to flip backwards. It's good physics. All right? Now your constant velocity. Again, distance over time will give you your velocity. Great. Now down here, you can see it. You're just going to take the one piece of data from this. You're going to take your time for your unknown distance. So you can put your times there. You know your velocity. In each case, it's going to be a range. You can't put a single velocity with any of these. You're going to be using your range of velocities. And from here, you're also going to determine your range of times. So your calculation at the end will be based on those ranges. All right, let me finish up this stuff, then maybe I could show you a little bit of your calculation. Your data here, data, would be your data table. You just put your data table. Your data table can be handwritten if you'd like. You certainly can put it on computer, but handwritten is acceptable as long as it's neat. And then your conclusion. Well, what would we conclude in this circumstance? What is the conclusion I seek? Am I looking for the length of the hallway? Is that my conclusion? I don't care about the length of the hallway. So what's the conclusion here? That measuring honestly involves reporting a range of measurements and using that range of measurements in your calculations. So at the output, you also have a range of possible answers. Welcome to reality. This is how measurements work. Measurements don't give you a single output. Measurements give you a range of possible outputs. And if you need a very specific output, you need to measure very, very carefully. Poor measurement or mediocre measurement gives mediocre results. The only bad part is thinking that mediocre results are the same as excellent results. Okay? So when doing my calculation, let's say my velocity goes from 1.05 meters per second all the way to 1.11 meters per second. Perfectly valid. That might be what my velocity is when I'm trying to hold it constant. Now, if my unknown time, my time for my unknown distance, goes from 61.3 to 66.4 seconds, how do I work these numbers to get the range? Now, statistically, you'd work it differently, but we're not worried about statistics right now. We're not worried about the best way to do this. What I'm really trying to show you is that the output really is a range. So if I take my shortest time and multiply it by my lowest velocity, I will get the shortest it could be. And if I take my highest time and multiply it by my highest velocity, I will get the longest it will be. And that's what I want you to report. That's what I want you to indicate for the length of the unknown distance. What's the shortest it could be? What's the longest it could be? And if you've done this right, almost certainly the hallway length is somewhere in between there. But as long as you've done this honestly and you've learned this method, you don't lose points in any case. So I think that's how I would like the labs written up. I don't want this to be an exercise in frustration. This is supposed to be, like most physics, have an element of fun associated with it. So see what you can't do about those ranges. See how interesting this is to mess with. See who gets the closest to reality. Ooh. But when we put all the numbers up, for those of you in school that are doing the same distance, you'll be surprised at how we put the ranges there, and in most cases it overlaps in some central spot. And even if I never went and measured the actual unknown distance, we could probably come up with a pretty good idea of what the unknown distance is just by looking at the ranges and how they overlap. All right? Thank you very much for watching.